All right, welcome to our unit on rocks, day 3. Your topic for today is Metamorphic Rocks, day 3 of 3. Today, we're going to compare and contrast organic and chemical sedimentary rocks and know how they formed. So we're going to review sedimentary rocks real quick, and then we're going to learn about metamorphic rocks and how they form. And then you will know how foliation forms in metamorphic rocks as a result of pressures and temperatures. Okay, pause this if you need more time. Here we go. Okay, so for your quick write, what would be left behind if you let a glass of salty water evaporate in the hot sun? If you add heat to a raw egg, what happens to it? What would happen to your hand if you kept stacking textbooks on top of it? What are some rocks you may have seen in a cave? What are some rocks that we use for energy? Okay, pause this while you complete your quick write. All right, so the first one we're going to look at are organic sedimentary rocks. So we need to finish sedimentary rocks here. Organic sedimentary rocks are rocks that have formed from once living creatures or organisms. For example, coal is a rock that we burn for energy. Many of our homes that we get our energy from is from a rock called coal. Coal is a carbon-rich rock that formed from the buried and compacted remains of dead plants. Limestone is a rock that formed from compacted and cemented shells and coral over here. So it formed from once living things. So we have coal, okay, ancient dead plants squished together, and then we got limestone, ancient and cemented and compacted shells and coral. Okay, so these are organic sedimentary rocks. Let's look at how coal formed real quick here. So it's an ancient forest, and this ancient forest in this black layer got buried and compacted, and then kind of heated, and we have this layer of coal. And then we humans dig down into the earth and dig this coal up for energy. Okay? Let's look at gypsum. Gypsum is a chemical sedimentary rock that formed when minerals precipitated or solidified out of water. Okay? So chemical sedimentary rocks are rocks that form when minerals precipitate or solidify out of water. For example, gypsum formed when lakes evaporate, leaving behind this crusty, white, salty stuff. That is gypsum. If you've ever been to Utah or Nevada in the summertime, you've seen these lakes evaporate and they leave behind a chalky white substance known as gypsum. Okay? So, gypsum formed when lakes evaporate, leaving behind solid rock here. So, in the summertime, this solid chalky white substance is gypsum. Okay? Another type of chemical sedimentary rock is stalactites in caves. Stalactites form in caves as dissolved minerals in water precipitate and solidify. They release their minerals to make solids into rock. Over time, these stalactites grow. So here are these stalactites in caves. Over time, okay, these calcium minerals precipitate out. That means they just turn into solids. And you get a new mineral forming, a new rock called stalactites here. Well, that's a chemical sedimentary rock when minerals precipitate out or solidify. Okay, and you get a chemical sedimentary rock. All right, so what's the difference for your notes? What's the difference between organic and, let me go back. What's the difference between organic and chemical sedimentary rocks? Question goes on the left-hand side, answer goes on the right-hand side. Use the answer bank to determine which words best complete the sentence. Okay? Write down the examples so you get them right on the test, please. All right, pause this while you write. All right, rock physical properties. Remember, rocks are classified how they form, but how would we tell rocks apart? Like these rocks right here. Well, sedimentary rocks, okay, one way we can tell sedimentary rocks apart is their sediment size, right? Sandstone feels gritty, like sandpaper. Siltstone is a finer grained rock, so it feels smooth to the touch. Okay? And sedimentary rocks can also have layers, like this sandstone here. You can identify it by layers of different sand. Or sedimentary rocks have fossils, because animals die, they fall in the sand, or the sediment, or mud, and they get preserved over time. So sedimentary rocks have fossils in them. So, how do we identify sedimentary rocks? So, pause this while you write. Question goes on the left-hand side. Answer goes on the right-hand side. Once again, just go ahead and pause this. Okay, this brings us to metamorphic rocks. Igneous rocks are born of fire, sedimentary rocks are formed by weathering and erosion, but how do metamorphic rocks form? The last type of rock we're going to study is called metamorphic rock. The word metamorphic or morph means to change, like a butterfly, right? It morphs from a caterpillar into a butterfly. But if we use the same concept and we apply it to rocks, rocks change by heat and pressure. Deep down in the earth, okay, rocks are subjected to tremendous amounts of heat and pressure. In order for us to understand metamorphic rocks, we need to understand how heat and pressure can change a pre-existing rock. So here's limestone. Remember, it's an organic sedimentary rock. Well, what if we add heat to it? It gets really hot. We make a rock called marble. And marble's a rock that's on the bottom of your trophies. Okay? So there's marble, a metamorphic rock. So when rocks are subjected to tremendous amounts of heat and pressure, okay, they change. They become new rock. They become metamorphic rock. Okay? It's kind of like if you keep stacking books on top of your hand. Well, eventually that pressure is going to build up and your hand will become smushed. Okay? So, for your notes, what are metamorphic rocks? Question goes on the left-hand side. Answer goes on the right-hand side. Use the answer bank to determine which words best complete the sentence. Go ahead and pause this, please. Okay, foliation. Pictured here is good old granite, intrusive igneous rock, right? It's igneous. But what happens if we apply pressure to granite and heat? Applying pressure will cause the minerals to flatten and become aligned. It becomes like taffy. It becomes stretched out and it smushes the minerals. So let's apply heat and pressure to granite here and see what happens. So if this is granite, okay, it's kind of like dominoes, right? If we apply heat and pressure, the minerals become flattened and smushed and stretched out and aligned. And we get a new rock called gneiss. Okay, very nice. So it was once granite. It's now a new rock, a metamorphic rock called gneiss, where the minerals have become smushed, flattened, and aligned. We call that foliation. Some metamorphic rocks, like gneiss here, have foliation. Okay, metamorphic rocks are classified as either having foliation, we say they are foliated, and non-foliated, having no foliation. So foliated metamorphic rocks include slate here. It's smushed and flattened. It looks kind of like layers, but it's not. They're just smashed, smushed together minerals. Okay? So slate and gneiss have foliation. They have smashed together minerals that have been flattened and aligned. Non-foliated rocks are like marble and quartzite here. There's no foliation. In other words, they're not smushed. They've just been kind of heated. All right. So we classify rocks, metamorphic rocks, by as either having foliation or non-foliation. Well, we've learned that some rocks like sandstone feel gritty and some rocks like obsidian have a glassy texture. Metamorphic rocks, though, are identified by their foliation. So when you rub your fingers against them, you should be able to hopefully identify foliation and non-foliation. Okay? So for your notes, okay, what is foliation? Okay? So, question goes on the left-hand side. Answer goes on the right-hand side. Okay, use your answer bank here to determine the word that best completes the sentence. While you write this, go ahead and pause this now, please. Okay, protolith. Before they were metamorphic rocks, they were either igneous or sedimentary rocks. For example, here's limestone. Remember limestone? It's a sedimentary rock, organic. If we add heat and pressure, it will change into marble. Okay? Well, limestone was what we call the protolith. It is the original rock from which the metamorphic rock formed. The table below summarizes some common protoliths. So limestone, before it was marble, it was limestone. We added heat and pressure, it became marble. Siltstone, we added heat and pressure, it became a new rock called slate. Sandstone, we added heat and pressure, became quartzite. And granite, if we added heat and pressure, becomes gneiss. Very nice. All right, so what is a protolith? For your notes, we got one more thing to write, and we're done. So, question on the left-hand side, answer on the right-hand side. Use the answer bank to determine which word best completes the sentence. Go ahead and pause this while you write, please. Alright, so the rock cycle. We just learned about the 3 types of rocks throughout the last 3 days of notes: igneous, sedimentary, and metamorphic. As it turns out, though, igneous rocks can change into sedimentary rocks or into metamorphic rock. Sedimentary rocks can change into metamorphic rock or igneous rock. Metamorphic rock can change into igneous rock or vice versa. So these things can change. All these rocks can change into each other. How does that work? Well, let's look at here. Let's say we have magma, hot molten rock. Well, what happens if that magma cools? Well, if it cools, it's going to harden into igneous rock, like basalt here, which is a lava rock seen on Hawaii. Okay, so igneous rock forms. But what happens over time if we apply the forces of nature? Water, wind, gravity. We're going to weather and erode that into sediment, right? Little bits and pieces of sand. We're going to break it down into sediments. Then, if we compact and cement that sediment over time, we make, for example, if we compact and cement sand, we make sandstone, a sedimentary rock. Okay? And then, if we add heat and pressure to sedimentary rock, we can make a new rock, a metamorphic rock. It's changed from heat and pressure. And then let's imagine we throw that rock back into magma. We melt it. We're back where we started. Okay, but it doesn't always go in this perfect, complete circle. Okay, what if I melt sedimentary rock? I'm back here at the beginning of the rock cycle. Okay, what if I add heat and pressure to igneous rock? I can cut across here over and become metamorphic rock. Okay, or what if I weather and erode metamorphic rock? I can make sand or silt or sand or sediment, basically. Okay, so that's the rock cycle. Last one for your notes today is the rock cycle. What is the rock cycle is your question. Your answer on the right-hand side, use the answer bank to determine which words best complete the sentence. Go ahead and pause this while you write. Okay, so summarize. I want you to draw this volcano here. Tell me where there's igneous rock, intrusive igneous rock, and extrusive igneous rock. Tell me where there's sedimentary rock. Look for those layers, right? Metamorphic rock. Look for that heat and pressure. Intrusive igneous rock is igneous rock forming inside Earth. Extrusive igneous rock forms outside of Earth. Okay? So draw it. You can always write your own. Okay? Make a nice drawing and fill the terms in, please. Okay? Congratulations, you're finished. Go ahead and pause this while you draw this, and have a great evening.